So first we will start with the power series. Basically, a power series is a more general term for a geometric series. The general term for a power series is the sum to infinity with n starts at 0 of Cn times x to the power of n, where Cn is usually a constant. So usually in a geometric series, C is 1, therefore it has a very simplified version of x plus x to the power of 1 plus x to the power of 2 plus x to the power of 3 and etc. etc. And similarly to the geometric series, the sum of the power series can be shown as c over 1 minus x. Just like in the geometric series, the sum of the geometric series is 1 over 1 minus x because c is equal to 1. So with the power series, there are a few exercises or a few problems that are related to it. Let me use a different color. Yes. Okay. So a few problems that you might see in the test in regards to power series is that you have to use differentiation or integration of each single terms to find the equivalent expansion of the power series. Like for example, they might ask for you to write the expansion of 1 over 1 minus x squared. So at first glance, you can see that it's pretty similar to the sum of a geometric series, which is 1 over 1 minus x. So we write that out, 1 over 1 minus x. And it is similar to x to the power of n. Because 1 over 1 minus x, the derivative of that would be negative 1 over 1 minus x squared. And so we take the derivative of x over n, which is n times x to the power of n minus 1. And then we move the negative sign over to the other side, which is 1 over 1 minus x squared equals negative n to the power of negative n times x to the power of n minus 1. And this here, right here, we're going to use another color pen. This right here is the general term for this thing. So it will be 0 negative n to the power of x, negative n times n to the power of n minus 1. So similarly, there are others one, which is 1 over 1 plus x. In this part, we will have to use integration to find the equivalent form using the power series. Okay, so now we will look at finding a power series by integration. The previous problem is when I relook at it, it's not sufficient enough. So now we'll try and do a different problem, which is find a power series to represent ln of 1 plus x. Okay, so you remember that 1 over 1 plus x, we can easily find the power series for this, which is because 1 over 1 plus x is basically the same as 1 over 1 minus x. And this right here is the sum of the power series, which can be written as the sum of negative x to the power of n. So how do you find the power series of ln 1 plus x? Because ln 1 plus x is the integral of 1 over 1 plus x. We can use integration to find the power series that represent ln 1 plus x. So basically, put integration there, x0 We can write a bit more clearer down here. ln 1 plus t is equal to x0 of 1 over 1 plus x, which we can write it out like each different terms, like 1 minus t plus t squared minus t third and more, using the formula, the general term that we have found above. So now we will have ln x0 using the integral theorem, the calculus theorem, and we just find the integral of all the terms on the other side, which will basically leave us with ln 1 plus x equal to x minus x squared over 2 plus x third over 3 and more, because ln 1 plus 0 is 1, is ln 1, and ln 1 is 0. And similarly on the other side, all these terms over here will, when 0 is replaced with t, when t is replaced with 0, it will basically all will be erased, all will be nullified. And so we have the general term, which is negative 1 to the power of n times x n plus 1 over n plus 1. And that is how you find the power series using integration and differentiation. So today we will move on to interval convergence. So with our knowledge from the convergence test that we have talked about in our previous video, we will move on to interval convergence and radius of convergence. So on the test, usually they will differentiate between these two terms. For the interval part and the radius part, I will tell you more about these two terms when we actually do an exercise down here. So the first exercise that I want to show you is find the interval of convergence for this equation. So naturally you will look for the appropriate convergence test to find these two. Usually it's either the ratio test or the nth root test. So looking at this, we can clearly see that the ratio test is more appropriate, so we will use the ratio test. It will be as always, un plus 1 over un, and this is all wrapped in the absolute value. And then we just flesh it out. And so when we look at this, we can see that we can simplify these two up here, and we'll be left with x squared outside, and inside we have 2n over 2n plus 2. Then we can take the x squared out, and because it was all wrapped in the absolute value, we can be x squared wrapped in the absolute value, limit n to the infinity of 2 over 2n plus 2, actually 2n over 2n plus 2. And looking at this, we can see that this limit goes to 1, and so what we all have left is just x squared. And so naturally, using remember the ratio test, that if you want this to converge, the final limit has to be less than 1. So this right here, 1, is the radius convergence. radius of convergence. So if your BC test only asks you to find the radius convergence, this is usually good enough. However, there are some cases where it could be, and you got the final result and the limit goes to 3x and it's less than 1. You have to do some algebra and then move the 3 over to the other side. And in this instance, 1/3 is your radius of convergence for whatever function that gives you this answer. Okay. And so from this radius convergence, you can easily find the interval convergence using basic algebra. So x squared less than 1, x less than 1, therefore, actually infinity x less than 1. So it's either x less than 1 and x larger than -1. So we don't know whether the function converge at 1 or -1. So we gotta plug in 1 and -1 into the function, into our original function to see whether they will converge or not. So x 2n over 2n. So at x equals 1, we will have, so plugging 1 into x, we will have 1 over 2n over 1 to the power of 2n over 2n. 1 over 2n is just 1. And so we will have 1/2 times 1n. And because if you remember from the convergence test, 1n is it's a harmonic series, and with our P3 test, 1n diverges, therefore this whole thing diverges. So x does not converge at 1. If we do it at -1, we will have -1 to the power of 2n over 2n. -1 over 2n is just -1 n times 1 2n. And we can clearly see that, -1 it reminds us of the alternating series. And with that in mind, we can see that this limit, it goes to 0, and each absolute value it decreases, therefore this thing converges. So using our knowledge from these two tests, we can see that the interval convergence for x to the power of 2n and over 2n is -1 to x less than 1. So it will include -1, but it doesn't include 1. And that is how you do a interval convergence test. So just bear in mind that whenever you have a problem where you have to find the interval convergence or the radius convergence, remember to try to isolate the x, make it outside of the limits so that you don't have to worry about that. And so with the x out of the way, the limit would just be your normal algebra function right here. And when you get to this point where you have the radius of convergence, remember to test the endpoints, because the endpoints are usually not included in your original calculation. So just do two more extra steps of testing the convergence at these two endpoints, and then you will have your final answer.